Greetings, math fans. All right, so this is day 5, and today's topic is sum of infinite geometric series. That's part of the topic today. So it's sum of infinite geometric series. Okay, so we have a nice little formula that we're going to kind of develop here. Let's just look at our old formula. Remember S sub n, this is for a geometric series. We have a sub 1 minus a sub 1 r to the n over 1 minus r. All right, so let's think of a couple of different things here. First of all, when n is so large, when it gets really, really big, and the absolute value of r is less than 1. Okay, so what is that going to be? What is r to the n? So let's just kind of do an example here. Let's say r is 1/2, and n is huge. You know, just 2 million. Okay, don't you guys agree? It's going to be, if I would actually multiply that out, it'd be 1/2 times 1/2 times 1/2, 1/8. So it gets 1/4, 1/8, 1/16, 1/37. So this is getting really small. In fact, it's getting close to 0, right? It's almost like it's canceling out. So it's getting close to 0. So what this part right here, what happens with this is, if that r to the n goes close to 0, if you multiply that by a sub 1, that goes away as well, right? So this is really out of here. And what you have is our new formula is s sub infinity, because it's infinite. That's when I say infinite, it means n is going to infinity. N is getting bigger and bigger and bigger. We just have what's left over, a sub 1 over 1 minus r. Okay? So you need to put some stars around this guy here too, because that is a very significant formula. S sub infinity equals a sub 1 over 1 minus r. Okay, it's an infinite geometric series. But math fans, this is super important. R, in order to use this formula, absolute value of r has to be less than 1, which basically means r has to be between -1 and 1. Can't equal 1, and it can't equal -1. It's got to be between those two values. Very, very important. If it's not, you can't use the formula. It'll work in there. You can actually plug it in and you'll get an answer, but it'll be a completely wrong answer. Okay? So let's start out with an example here. Find the sum, and you're given 8, 4, 2, 1, dot, 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 dot. Now here's the deal. Those dot, dot, dots right there, that means infinite. Please recognize that. So don't come up to me in the middle of a test or middle of a quiz and go, Mr. Curtis, is this an infinite or is it a finite one, the regular one? Because I'll tell you, go sit down. Because you guys should look at that dot, dot, dot and go, oh, wait, it keeps going. So I want to find the infinite geometric series, right, to find out what it's actually going to add up to as you keep going. All right, so anyway, right, we need, let's write our little formula here. It's s sub infinity equals a sub 1 over 1 minus r. Pretty easy. We need two things. We need r. Well, isn't that 4 over 8, which is 1/2? And again, check it. R equals 2 over 4, 1/2. Okay, that's good. And a sub 1 is 8. Wow, that's all we need. Pretty sweet. S sub infinity is equal to 8 over 1 minus a half. So it's basically 8 divided by a half. You could always do this all in your calculator in one shot, and our answer comes out to be 16. Okay? Really pretty easy. Great formula. Okay, let's try another one here. Find the sum. So it's going to be -15, 3, -3/5, 3 over 25, dot, 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 dot. Okay, so you know infinite geometric series. R is, let's just make sure, it's 3 over -15, which is -1/5. Let's try another one, -3/5 over 3. Same thing as -3/5 times 1/3. And that gives us negative 1/5. Okay, good. So r is negative 1/5, and a sub 1 is negative 15. So we just plug in our formula. S sub infinity equals a sub 1 over 1 minus a negative 1/5. Okay, so watch it, right? It's really 1 plus 1/5. I don't care how you do that, but I would do the negative 15, and then I would put divided by in parentheses, and you could say 1 minus a negative 1/5, or just recognize it's 1 plus 1/5. And your final answer comes out to be negative 25 over 2. Okay, not bad. Try another one here. Find the sum. So we got 1/9, 1/3, 1, 3, dot, 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 dot. Okay, so it's an infinite geometric series again. And we got to find r. So r is going to be 1/3 divided by 1/9, or times 9 over 1, right? Got to do the reciprocal. And so we get 3. Check it again. 1 divided by 1/3 is the same thing as 1 times 1/3, or 1 times 3, which is 3. Okay, good. So we know r is 3, and a sub 1 is 1/9. So it's s sub infinity equals a sub 1 over 1 minus 3. So if you divide that out, we get negative 1 over 18. Okay, everybody good with that? Boo! Wrong! Why is it wrong? Well, think logically. Do you even see any negative numbers up here? 1/9 plus 1/3 plus 1 plus 3. They're all positive numbers. So what the heck is wrong with this thing? Well. R is equal to 3. Okay, think about it, guys. This is getting bigger and bigger and bigger. You can't find the sum of it. It's just growing bigger and bigger and bigger. Okay, so r always has to be between negative 1 and 1, and r is equal to 3. Can't have it. Okay, so you actually can't do this problem. Can't do it. And let's talk about some words now. If the absolute value of r is less than 1, which is what we talked about, we say the series converges. All right, so converges means it basically approaches a finite number. So let's write that down here. It approaches a finite number. Okay? So that's why it works when it goes, for all the first two examples, it actually approaches a certain number. Okay? If the absolute value of r is greater than or equal to 1, okay, then we say the series diverges. Very important word. So converges and diverges. And the word diverges basically means it doesn't approach a finite number. Doesn't approach a finite number. Okay, what I mean by that is negative infinity, positive infinity, or if it goes back and forth like 1, negative 1, 1, negative 1, 1, right? It goes back and forth. It's not approaching anything. It's going the same amount back and forth. So those are examples of where it does not, or diverges, doesn't approach a finite number. Okay? So remember, r has to be less than 1. Absolute value of r has to be less than 1 in order for this series to converge. And if it's greater than or equal to 1, then it's going to diverge. Okay? All right, so let's take a look at a couple different problems here now. And if I have n is equal to from 3 to infinity. So you can see right away I've got an infinity on top there, and that infinity means infinite geometric series. Got to recognize that. Okay? The other ones were between 3 and 5 or 3 and 10. This is infinite geometric series. So it's, let's put one out here, 2/3 to the n power. Well, basically what I need is, remember, it's s sub infinity equals a sub 1 over 1 minus r. So what's our value of r? Well, that's really easy. R is always in that parenthesis right there. R is 2/3. How do I figure a sub 1 out? You plug in the first value of n. So the first value of n, which in this case is equal to 3. I plug it into the formula. So it's really 2/3 to the third power, which is 8 over 27. That's a sub 1. So s sub infinity is equal to a sub 1, which is 8 over 27, divided by 1 minus 2/3. Okay, and if I divide that out, again, parentheses here, divide in your calculator, you get 8/9. That's what it converges to. So I'll write here, converges to 8/9. Okay, let's try another one. Sum, and it goes from 2 to infinity, of 3 times negative 1/2 to the n power. Well, r again is really easy, negative 1/2, and a sub 1, take that 2 and plug it in. So it's 3 times negative 1/2 squared, right? So that gives us 3 times 1/4, which is 3/4. And then s sub infinity, which my r is good, it's between negative 1 and 1, so I can use it. S sub infinity equals a sub 1 over 1 minus negative 1/2, or 1 plus 1/2. Okay, and if you divide that out, you get 1/2. Okay, pretty easy, pretty easy. And you know, just for the heck of it, if you had something like this, n goes from 5 to infinity, and it was 3 times, 3 halves to the n power, you can't do this, right? R needs, the absolute value of r has to be less than 1, and it's not. It's 3 halves. That actually, this one diverges because it keeps getting bigger and bigger and bigger and bigger and bigger. Okay? So let's remember a few different sigma notations here. So you go, n goes from 2 to 10 of 4n plus 3. What is that? You guys should remember that's an arithmetic series, where in that case d is 4, right? Okay, then we have n goes from 2 to 10 of 2 and then 3 to the n power. And again, you guys should remember this is a geometric series where r is that number that's being raised to the power. So r is 3. Okay, and then you have n going from 2 to infinity of 4 times negative 2/3 to the n power. And of course, this is an infinite geometric series. Okay, in this case here, r is equal to negative 2/3, so I can use my friendly little formula because it's between negative 1 and 1. Okay? What I want to remind you guys of is for all these problems, for like all the sigma notation, you're going to have to find a sub 1. So to find a sub 1, basically what you have to do is you got to plug in the first value of n. Plug in the first value of n. That is so important. Okay, you got to plug in the first value. So like these will all be 2. A sub 1 is always 2 for all of these. Got to plug that in. Okay, and real quickly, for arithmetic, to find the last term, so find the last term by plugging in the last value. Plugging in the last value of n. So going up to this top here, your a sub n, your last term is that 10, right? It's a sub 10. Or it's just plugging in 10 in it, so it would be 4 times 10, which is 40, plus 3 is 43. That would be your last term. And also remember, for these, the number of terms, which you need to know that for these two, right? N is going to be n, which is, like I said, number of terms, is basically 10 minus 2, the top minus the bottom, plus 1. So in this case here, it would be 9. Okay? Very, very important. All right, so let's talk about our last topic here. All right, so our last topic is arithmetic means. Very scary. Sounds very negative, doesn't it? Basically, an arithmetic mean is an average. That's all it is. I mean, think of it. The mean of two numbers, right? The mean is the average. So let's kind of do a quick example here. If I said 10 and 20, what's the average of that number? Isn't it 10 plus 20 over 2? So 30 over 2, which is 15. So 15 is my mean. All right? So what I want you guys to do is I want you to think about an arithmetic sequence. So think about an arithmetic sequence. Okay? The reason I want to ask you that is because what do you add to 10? So what do you add to 10 to get 15? So what do I go from here to here? Well, I add 5, right? So in this case here, if you think about it as an arithmetic sequence, D is equal to what? D is equal to 5. So math fans, this is our goal. When we're finding the arithmetic mean, our goal is to find the value of D. Okay? And let me show you by an example here. My example is find two arithmetic means between 8 and 17. So what I want you guys to do is, you know it's 8, and then there's two arithmetic means, and then 17. So I'm trying to figure out the value of D to add to this, and then to add to this, and then I'll finally get 17. So guys, this is just like using our old arithmetic sequence formula. I'm giving you a sub 1, this is a sub 2, 3, and I'm giving you a sub 4. And you got to find D. That's easy, right? It's a sub n equals a sub 1 plus D times n minus 1. We got everything here. That's the last term, so it's 17. That's the first term, 8 plus D, which we're looking for, and n, well, n was 4 because that we went up to the fourth term. So 4 minus 1. So I'm going to move the 8 over, and I get 9, and that's 3D. Divided by 3, D is equal to 3. So once I have this, math fans, I am almost done. Literally what I need to do is take that 3 and then add it to the first term, and I get 11. And then I add 3 again, and I get 14. And just to check it, you better get that number, and it does. Okay? So our answer is 11 and 14. Those are the two arithmetic means between 8 and 17. Okay? It's really not that bad. Hey, but again, this last guy right here, it's a good idea when you're adding it, and to check it and see if you make sure you get that last number. Okay? So that's pretty easy. Okay, so our last example is geometric means. Similar concept to arithmetic, except now instead of adding, you're going to be multiplying. So what do you think our goal is? Our goal is to find R instead of D. Okay? So here's your first example. It's find the 3 geometric means between 2 and 162. So you're going to go 2, and then you're going to put 3 blanks here, and you're going to list 162. So just like I did before, that's a sub 1, this is 2, 3, 4, and this is a sub 5. So our goal is is to find r. Because once I find r, then I just start multiplying it out. Okay, so let's use our friendly formula. A sub n equals a sub 1 times r to the n minus 1. All right, and so by a sub n is going to be a sub 5, so it's 162 equals a sub 1, which is 2, times r, which we're looking for, and then that's going to be to the 5 minus 1. Okay, so we divide by 2, and we get r to the 4th equals 81, and because this is an even root, we get what? Well, the 4th root of 81 is 3. 3 times 3, 9, times 3, 27, times 3, 81. Okay, so it's plus or minus 3. Very important. Because now when I get my answer, I have two sets of answers. So two sets of answers. One is going to be 2 times, let's do positive. So 2 times 3 is 6. Times 3 is 18, times 3 is 54, and then to check it, because we got our three values, right? We got this value, and this value, and then to check it, we're just going to multiply it out again times 3, and that gives us 162. Okay, that's not our answer, but that's the check. Now, I use positive 3 here, but now we're going to use negative, okay, to test it out. So it's going to be 2 times negative 3 is negative 6, times negative 3 is 18, times negative 3 is negative 54. Again, to check it, times negative 3, that gives us positive 162. Okay, so if I multiply, or if I look at the values here, right, my answers, right, I have, there's my negative 3 here, which again, that's what r is, and then my answers are going to be negative 6, positive 18, negative 54. Okay, two sets of answers. So again, we can kind of list them. It's 6, 18, and 54. That's one set of geometric means, and the other set is negative 6, positive 18, negative 54. Okay, two sets of answers. Okay, so that's really not that bad. What I want you guys to understand is, if this is like this root right here was, right, it's 4 there, it's an even root. So you guys remember, if it's an even root, even, or really you should say even power, is two sets of answers. If it came out to be an odd power, then it's one set of answers. Okay? So that is pretty much it for this topic here. Like I said, we kind of covered quite a few things. We did infinite geometric series, and then we did arithmetic means and geometric means, and did several problems with that. So that's it, math fans. Hope you guys learned something, and you guys have an outstanding day. Adios. Goodbye.